Okay. Let's have a look then. Okay, what we got? It's looking good now. So today we're going to start our new unit. We are working with probability in this unit. We'll do this unit in two halves. The first half is simple probability. Second half will be probability distributions. We need to understand theoretical and experimental probability a little bit today. So on a fair six-sided die, what is the probability of rolling a 6? So this is hopefully from middle school, reminding of how to do these type of things. To find the probability of an event X, you need the total outcomes that produce X divided by the total possible outcomes. So for finding the probability of a 6 on a dice, there's only one side that will give you a 6 out of a total of 6 different sides. To find a prime number, we need to know what the set of prime numbers are, which are also available on a die. So prime numbers are given by the set 2, 3, 5, 7 onwards, but on the six-sided dice, this is the complete set. Our total outcomes. So our total outcomes on a die is 1, 2, 3, 4, 5, 6. So the probability of getting a prime is going to be 3 out of 6, which we simplify to 1 out of 2. We need to figure out what a factor of 16 is. So this particular set, factors of 16 are 1, 2, 3 is not, 4 is, 5 is not, 6 is not. So there we go. So again, this is going to imply that the probability of a factor of 16 is equal to a half. All right, pause the video for a minute. Discuss with your table partners what the likelihood of each of these outcomes, and then consider how do you come and find out those particular values. Pause the video now. Okay, welcome back. Discuss the likelihood of each one of these outcomes. So that the team winning from the FIFA World Cup in 2030 will be from the Americas. How would we work this one out? What is the likely probability? So to work this one out, your best way to do it is to look at past data. So how often has a team from the Americas won it compared to how often have they not? So looking at the data, because we're doing 2030, that's a few years from now. So current form is not really going to help you with that because it's going to be different players playing at that particular time. So you're going to use past data. And if you look over past data, you'll find that half the time it's won by a team from the Americas and half the time it's won by the team from Europe. So A is going to go about there. Past data is what's going to help us. It will rain tomorrow. So for a statistical, this isn't a great question here in Dubai because it's going to be pretty low. But wherever you do it, the way we normally come up with this is looking at past data, looking at the likelihood of it. But we can also look at current trends. So if it's raining today, it's more likely to be raining tomorrow. So it's going to be a combination of past data, as well as we can collect other data. We can collect scientific data, looking at the weather patterns coming in. We're generally looking at how the weather's progressing across from Oman into this direction, and at the moment it's going to be looking pretty low for that one. Humans will reach Mars by 2050. Now, on this one, we're going to be looking at collecting data again, seeing what's happening. We can see that there has been a lot of progression happening in this direction. There are some plans to get to Mars. So this one is quite likely, actually. I'm not sure why. Hopefully they'll send Musk and Trump there and just leave them there. Choosing one digit at random from a decimal expansion of 1.6. So get your calculator. Type in 1 divided by 6 and look at the decimal expansion. You'll see that 1/6 is equal to 1.66, is equal to 0.166 recurring. So how likely is it to get a 1 from this? Well, it's almost impossible. Almost impossible. Why is that? Well, because there's an infinite number of sixes. So there's not 3 sixes or 100 sixes or 1,000,000 sixes. There's an infinite number of sixes, and there's only one 1. So it's almost impossible. Almost impossible. The world will be free of all dictators within the next 10 years. I used to be a little bit more optimistic on this one, but under the current trends of how things are going, I'm more likely to suggest that the USA will have a dictator in the next 10 years than freedom. Okay, so this one's looking bad. The sequence 99999 is found somewhere in the first 1,000 digits of pi. So it's possible. I don't actually know the answer to this one. I know how it kind of looks, but it's not likely that we're going to get that one, is it? It's not likely. We could actually find the answer, and then it would become 0 or 1 when we actually see what the actual answer is. But I don't think it does. Experimental probability. So experimental probability is if we wish to find, if we go back to our first one, this here is theoretical probability. So we're using the fact that a die is a cuboid, like this one. Here is our die. We're using the fact that this is perfectly symmetrical, and we can sort of determine how many ways it's going to fall. But sometimes the more complicated events, we need to perform an experiment to find the probability. And what we do here on this one is we perform an experiment and then we repeat it. And we repeat it more and more and more times. So to define, if you have an uneven die, so often in questions you'll see it says a fair die is rolled. Well, let me see if this question, look, it says a fair die is rolled. That means it's like this. If it's not a fair die, if it's the opposite to that would be a biased die. So if a biased die is rolled, we can't use the shape to determine the probabilities. We would have to use experimental probability. What you would have to do with a biased die is you would have to roll it 1,000 times. Count how many times you get a 1, 2, 3, 4, 5, and 6, and then use those probabilities to be able to create your experimental probability theory on how it will react. So a couple of key words here. If we did an experiment, you'd have to do 1,000 trials. You'd have to record each outcome. And so you have to figure out what would happen would be what's the likely event in rolling it when you look at the total lot, and all of that data collected with 1, 2, 3, 4, ... And let's say we get 60, we get 100, we get 60, we get 60. This would be our sample space with all the possible outcomes. So theoretical probability, as we have seen, is the number of elements in the event divided by the number of elements in the total sample space. So I talked earlier about it being, let me just show you what I talked about earlier. the total outcomes in order to get x divided the total number of possible outcomes. So this is the number of elements in set x and divided by the number of elements in the universal set, which is the total sample space. This is the formula for theoretical probability, and we've seen that it can only be between 0 and 1. If you get an answer for a probability which isn't between 0 and 1, you've made a mistake. You have to do some exam-style questions. Oh, actually, no, there's practice questions, these ones. So find the probability of each event and decide which event is least likely. So we need to calculate the probability of t. In order to do that, we need to find the set t. We have a four-sided die. So our universal set or sample space is going to be the numbers 1, 2, 3, and 4. So in order to find a factor of 24, our set now is going to be 1, 2, 24, 3, 8, 3 eighths are 24, yep, and 6 fours are 40. So a factor of 24, these are all factors of 24. So the probability of event t is going to be 1. Throwing a prime number on an 8-sided dice. So this time O, the set O, 8-sided die, so we're going to have the prime numbers 2, 3, 5, 7. So here the probability of event O is going to be 4 over 8 a half D. Throwing at least 11 on a 12-sided dice. I think I can go straight to that one. So the probability of x being less than or equal to 11, at least 11, less than or equal to at least 11 is going to be 11 over 12. C. So the probability of event C is going to be the probability that x is at most 3. So, oops, sorry, I got this one well wrong. At least 11 means it has to be 11 or 12. So this is going to be 2 over 12, 1 over 6. And here we want at most 3. So 3 can be included. That means we've got 1, 2, 3 out of a total of 6. So this one is a half. I throw a multiple of 5 on a 20-sided dice. Oof. So we just do the set to begin with for I. A multiple of 5 would be 5, 10, 15, 20. These are all multiples of 5. So the probability of event I is going to be 4 over 20, which will be 1 over 5. All the dice are there. So which one is the smallest number here? So everything is 1 divided by something. So 1 divided by 6 has to be less than 1 divided by 5. So this has to be the smallest and least likely event that we have there.
Sorry, where? What did you say?
Okay, so continuing with this, let me just... Okay, for expectation. If there are n trials in an experiment, the probability of an event occurring occurring is P for each trial. Then the expectation of the occurrence is N times P. What this sort of means is if we flip a coin, your probability of getting ahead is going to be a half. So what is the probability of getting ahead? What is the expected number of heads that you would get? So in A, the expected value of a head in this event, so each trial is a half. So if we have 14 trials and the probability of success is a half, then the expectation is going to be 7 of them will be heads. Now, is that going to be true? No. It could be, it might not be. If you take a coin and you flip it 14 times, count it. How many heads do you get? You're going to get 6, you're going to get 8, you're going to get 7, you're going to get 5, you're going to get 2. Most of the time, you're going to get 7, 6, and 8. Now, if you repeat that event, if you repeat that and you do it many, many, many times, then you will start to get so many more 7s than anything else. B. Statistical data built up over 5 years shows that the probability of a student being absent at school is 0.05. If it must obviously not be in a test that day. There are 531 students in a school. Predict the number of students you expect to be absent on any given day. So the expected absence is going to be, we have 531 trials. The probability of success of finding a student that's absent is 0.05. Let's take out my calculator for that one. We get 531 multiplied by 0.005. We're going to get 26.55. So we would expect 27. This is an exam style question. Okay. A coastal town carries out a survey of tourists in July 2018. The accommodation type chosen and the age of the tourists are recorded in this two-way table. The information is given here. A tourist is chosen at random from the survey to receive a promotional offer. Determine what age group the tourist is most likely to belong to. So we've got our different age groups there. We need to figure out what is the total of each one. So we need our totals over here. Let's go across adding them up. 67 plus 81 plus 125 plus 32. There are 305 of these. 107 plus 230 plus 73 plus 119. There are 529 here. 87 plus 76 plus 34 plus 89. It's 286. 109 plus 32 plus 15 plus 54. 206. Now, we want to find out what's the total number of tourists. Let's add all of these up, going down. So we've got 305 plus 529 plus 286 plus 206. That is 1326. So 1326 here. A tourist is chosen at random from the survey to receive a promotional offer. Determine the age group of the tourist is most likely to belong to. Well, it's obviously going to be the biggest group on this case. So in part A, he's going to come from the age group 31 to 50. B. Find the probability that the tourist chosen belongs to this age group, expressing your answer as a decimal. So B. The probability of age 31 to 50 is equal to 529 over 1326. Put that into our calculator. 529 divided by 1326. Control Enter. And expressing your answer as a decimal. You need 0.39894 ... round it to three significant figures. 399. C. In July 2016, 16,000 tourists are predicted to visit. If the town's hotels have a capacity of 5,000, predict if the town has enough hotel capacity to meet demand. So we need to find out what is the probability of somebody staying in a hotel. So we need to add this column up as well. Here. We're going to need 67 plus 107 plus 87 plus 109. So this is 370. So the probability of somebody wanting to stay in a hotel, according to our statistical data, 370 over 1326. Which is roughly equal to 0.280. Now, what is our expectation that in our next event, what is our expectation that they will want a hotel? The expectation they want a hotel is 16,000 multiplied by our probability. So if we multiply that by 16,000 people, we'll get the expectation. The expectation is 4477. Now, to get the reasoning point, we have to always do, so this type of question is always a reasoning point in this. You always have to show an inequality on this type of a question. We say that 4477 is less than 5,000. This implies, and then we interpret and give our answer. There will be enough capacity. Okay, that's it for today. Have a go at the homework questions, exercise 7A and 7B. When you're done, take a photo of your answers and upload them to the Google Classroom. Thank you very much. We're finished there for today.